Alright guys, so we are on to the final upload here, and we are beginning from this question. Of course, this is where we had stopped in our previous upload. Alright, do want to take the time out here to apologize for uploading the past paper in parts. This is definitely the final upload. This will take us to the end of the paper, but going forward, any other past papers that I will be uploading, I'm going to try to upload them in no more than 2 parts. All right. So with that said, let's continue. All right, so please do watch the previous video to see how we had got the solutions here and here and here. Okay, so we are asked here to determine the speed of the cyclist determine the average speed of the cyclist over the 40-second period. Now, in order for us to do this, let's first establish what is the formula for speed. All right, average speed per se. So we can say that average speed is equal to the total distance traveled divided by the total time it takes to travel that distance. Now, if we go back to our graph, you'll recognize here that we're not dealing with a distance time graph, but we're dealing with a speed time graph here. And what you need to understand is that you're going to need to establish what is the distance that was traveled by the cyclist from a speed time graph. Now, in order for you to do that, you're going to have to find the area that subtends the starting point of the cyclist to the ending point of the cyclist. Now, the cyclist started from 0, and the cyclist went up to A, and the cyclist went to B. This is the stopping point for the cyclist. Now, we're going to have to create a shape here. We're going to have to create a shape here. Alright, so this is going to be a trapezium. Here you can see the shape. And so by creating this shape here, this trapezium, we're going to have to find the area that is underneath this distance, the speed time graph, which is going to be this trapezium. Now, a lot of you that are watching this video perhaps don't remember what the formula for a trapezium is. So, like I always say in all my videos, that you always need to check your formula sheet provided to you by CXE to see if there's anything that is there to your aid. So you can see the area of trapezium is A is equal to half A plus B times H. Let's read here. It says where A and B are the lengths of the parallel sides and H is the height. So we're going to take this formula here and we're going to bring it to the page that we were before. So if that is the case, then we're going to go here and we're going to have it that the distance, or the total distance, is equal to half A plus B times H. Alright, now A and B represents the parallel sides. So if we go back to our diagram, we can see that the parallel sides would have been here and here. This would be your perpendicular height. Yes, so let's look at what A and B and H are. The values of A, remember the scale, that each of these squares right here is going across by 5. See, 5, 10, 15, 20. So we're at 25 and we ended at 40. So this looks to be 15 because each square is 5, so 3 5 is 15. So A is 15. B is the starting to the ending, so that's 40. So B is 40. And the scale for this here is going up by 2.5. So 2.5, 4, sorry, 2.5, 5, 7.5, 10. But you can clearly see the 10 right here. So this is 10. So therefore, we're looking at half. A is 15, B is 40, and H is 10. So this is just half multiplied by 55 multiplied by 10. Right, so we could say half of 10 or half of 55, whatever the way that you want to do it. You could just go on your calculator. You should get an answer that the distance is equal to 275 meters. Alright, so that's 275 meters. Oh, sorry about that, guys. Alright, so that's the total distance that is traveled by the cyclist. So to wrap this all up, we already know the formula. We had written it here. So we have the distance, the total distance traveled by the cyclist, and we already know the time that it took for him to travel that distance, which is approximately 40 seconds. So therefore, average speed is equal to 275 meters divided by the time, is 40 seconds. And if we go on our calculators to calculate what that is, then we would find out that the average speed traveled 275 divided by 40, and that's equal to 6.87 meters per second. Alright, and that is the average speed traveled by the cyclist over the journey of 275 meters. Okay, so hopefully you guys got that. We're going to move on to the next question. Now, it says here, part B, consider the following pair of simultaneous equations: x squared plus 2xy equal 5 and x plus y equal 3. And it goes on to say that without solving, you have to show that 1 and 2, or 1, 2, is a solution to the pair of simultaneous equations. Now, the first thing that I want you to pick up for me here, guys, is that you're not dealing with the standard simultaneous equations where both equations are linear. You're looking at one of the equations here being non-linear, or what I refer to sometimes as being a quadratic equation. And then you're also looking at the other one being linear. So if we were to sketch these graphs of these equations separately, one would look like this and one would look like this, something of that sort. Alright, one is going to be a curve, a parabola, and one is going to be a straight line. So that's what we're looking at. Yes? Alright, so once we have an understanding of what that is, now we can't use the typical elimination method for this. We're going to have to use the substitution method for this. Alright? And it even goes on for the first question to say that we are not supposed to solve it, but we're just supposed to show that 1 and 2 is a solution for the simultaneous equation. Now, to do this is not really difficult, right? Because all you have to do is to substitute x equal 1 and y equal 2 into this part of the equation, and if both sides are equal, then 1 and 2 is a solution to the equation, or to the equations. But by the nature of the question, guys, you can obviously see that it will be. They just want you to show how you would prove that it is but we already know 1 and 2 is a solution based on the nature of how the question was asked. So we're just going to do that. We're going to square the 1 plus 2 times 1 times y, we said is 2, and it should be equal to 5. Now if both sides are equal to 5, if 5 is equal to 5, then 1 is a solution. So we have 1 squared, and 2 times 1 times 2, that's 4, that's equal to 5. So 1 squared is 1, 1 plus 4 is 5, so 5 is equal to 5. So therefore, if that happens, then 1 is a solution to the equation. We're going to do the same thing for the second equation. So x is, let's erase here so you can see clearly, x plus y is equal to 3. So that means x is 1 and y is 2, and that should be equal to 3. And 1 plus 2 is equal to 3, so 3 is equal to 3. Therefore, 1 and 2 is also a valid solution for equation number 2. So that basically is what we're going to do, or that is basically what you need to do to prove that 1 and 2 is a solution to the pair of simultaneous equations above. Alright, and that is without solving. Now we are to go on further to solve the pair of simultaneous equations above to determine the other solutions. Alright, and so to do this, as I mentioned earlier, we have to use the substitution method. We can't use the typical elimination method that you would have learned many times in school, simply because one of the equations is linear and one is non-linear. And I had drawn a graph earlier, just kind of quickly demonstrating what that is. But when I say the graph is non-linear, it means that the graph is a curve like that, and the second equation is a straight line. So what's basically happening here is that we already know that x is 1 and y is 2. We already know one value for x and we already know one value for y, but there is also another value for x and another value for y that satisfies the equation also. So why is it that we have 2 values for x and 2 values for y? Because here it is, this graph is not accurate, it doesn't match this particular equation, but it is just a demonstration. So the 1 and 2, let us just say that this is the value of 1 and 2 right here. That's what we know, 1 and 2. Remember guys, that this is not the value of 1, 2. This is like more likely negative 1, 2. But that's not the concept I'm trying to show. I'm trying to show you what the graph actually would look like if you were to sketch it. So what we know at the moment is that we know this value. What we don't know is this one. This is what we're searching for right now, xy. That's what we're searching for. Alright, so that's why they're asking you for another value of x and y. So hopefully that demonstration makes a little bit of sense to you. So we're going to use a typical method. Alright, sorry, not the typical method, we're going to use the substitution method. So here's what we're going to write. We're going to say, alright, from equation 2, here's equation 2, we're going to try to make either x or y the subject of the equation. I'm just going to just make y the subject of the equation. If you want, you could make x the subject of the equation. It doesn't matter, you're going to get the same answer. Alright, so I'm going to make y the subject of the equation simply by subtracting x from both sides, because I'm currently adding x to y. So I need y to be alone. I have to subtract the x over here and over here. So I'm going to have, when I subtract x over here, it's going to disappear, and I'm going to subtract it over here. I'm going to have y is equal to 3 minus x. So from equation 2, y is equal to 3 minus x. I'm now going to sub 3 minus x for y in equation 1. This is equation 1, guys. This is equation 2. I had created a third equation by using equation 2 to create y is equal to 3 minus x. So this is my third equation, which I'm going to be using a bit later. so I'm going to be holding this equation for later. So I'm going to be, because I used equation 2 to create equation 3, I'm going to take equation 3 and substitute it in equation 1. Alright, so that's what I wrote here. So anywhere I see a y in equation 1, I'm going to substitute 3 minus x. So here's equation 1. We have x squared plus 2xy, so that's going to be 2x times the value of y. I will know that the value of y is 3 minus x, and that's going to be equal to 5. Very good. So we're going to simplify this equation down to a quadratic equation and then solve it. So x squared plus 2x times 3 is 6x, and 2x times minus x is minus 2x squared, and that's equal to 5. Now we have a quadratic, but we also have a little problem that we have to kind of smooth out to make the quadratic solution come to life a lot easier. So we have a problem where we have the coefficient of the x squared. The bigger coefficient here is this 2, which has a negative sign, so we need that to become a positive in some way or form. So we're going to have to do some transposition. We're going to have to make all the variables equal to 0, as we normally do, and then solve, but we have to try to make this one a positive. And to do that, we're going to have to transpose the negative 2x squared over here. So we're going to bring everything over to where the 5 is. So we're going to bring this negative 2x squared over here. We're going to get 2x squared positive. We're going to bring this x squared at the same time over here. So we're going to have minus x squared. We're going to bring the 6x over to the right hand side where the 5 is. We're going to get minus 6x. And then we already have the 5 over there, so that's going to be plus 5. And now everything is equal to 0. Alright? So by simplifying this, we're going to have 2x. Okay, well that's not right, because 2x squared minus x is going to be x squared. We're going to have minus 6x plus 5, and that's equal to 0. Alright, so we end up with a quadratic equation. Alright, so let's solve this by using the AC method. So we're going to have x squared minus 6x plus 5. And this AC method is just basically 1 times 5, and that's equal to 5. And the factors of 5 is a prime number, so it only has 2 factors, which is 5 and 1. And the only way to get negative 6 is to make the 5 negative and the 1 negative, so that we can get negative 6 when we add them. So with those being our factors, we're going to have x squared minus 5x minus x, or minus 1x, there's a 1, so just 1x right here, plus 5. Do check out my quadratic equation video on my channel to see a clear and more detailed explanation of what I'm doing here. Alright, but you should have an understanding if you're at this point in the video. So x squared, we're gonna group them into pairs of 2. Alright, so we're gonna factorize the first 2, factorize the second 2. So we're gonna have x open bracket x minus 5, because x is a common factor for the first 2, and the only common factor of negative 1 and 5 is negative 1. That's going to be x minus 5, and that's equal to 0. Alright, so now what we have now is that x minus 1 as a factor, and we have x minus 5 also as a factor. Those are equal to 0. So if both brackets are equal to 0, then we can solve it by saying x is equal to 1 and x is equal to 5. So we've just established the fact that 1 is a solution for x, which we had initially established here. They had told us that x was 1. And we know that when x was 1, y was equal to 2. We established that. So the other value for x that they were actually focusing on was that the value of x is equal to 5. So we want to know what is the value of y when x is now equal to 5. I'm just going to put it right here. So since as we have this third equation, I told you that we're going to come back to this later. This is the later. We're now going to sub 5 4x in equation 3. And that simply will give us that y is equal to 3 minus 5. So y is equal to negative 2. So that wraps it up. When x is equal to 1, y is equal to 2. And when x is equal to 5, y is equal to minus 2. And that's the solution to that equation. Alright? So that pretty much wraps up that question. 5 marks. Good amount of marks for that amount of work. We're going to move on to the next question. So we're on to the measurement, geometry, and trigonometrical section of the paper. And we're going to kick off this section here with circle theorem. Alright, so we start off by seeing here that P, Q, R, and S are 4 points on the circumference of the circle shown below. Let's identify those points, guys. P, Q, R, and S. And we also recognize here that the angle QRS is 58. So angle QRS, remember that when an angle is named with 3 letters, the angle is located at the letter that is in the middle. Hence why the 58 degrees is right here. Our first question here is to use geometrical properties of the circle or of a circle to give reasons for each step of your answer. And by doing that, you are to determine the value of the angle SPQ. So the angle is located at P, which is down here. SPQ, this angle. Now, if you're not familiar with the geometrical rules for circle, you need to get familiar. And by looking at this diagram, what you can see here is that this line in the instruction here, this line has basically given me the answer for that. How has this line been the solution for this question here? Because what this is saying to me here is that PQRS are 4 points on a circumference of a circle. And I know that one of the geometrical statements of a circle is that if 4 points lie on the circumference of a circle and they are connected, then the shape that is created within the circle is what we refer to as a cyclic quadrilateral. So it's referred to as a cyclic quad, because you can see that there is a 4-sided figure that is inscribed inside the circle. And so one of the geometrical rules for a circle with a quadrilateral inscribed inside of it is that the opposite angles are supplementary. And what does it mean by angles being supplementary? It means that the angles that are facing each other inside the quadrilateral, the sum of those angles will add up to 180. So in essence then, we can safely say that the angle SPQ is equal to 180 minus 58, which works itself out here to be equal to 122 degrees. And so your reason, your geometrical reason, is going to be opposite angles are supplementary. If you're unable to remember the word supplementary, you just simply write opposite angles inside the quadrilateral adds up to 180. But I'm just going to use the word supplementary. And you are allowed, guys, to use shorthand writing, right? Because the marker does understand what OPP, angle S, or angles. They know what it means. All right. So that takes care of that question. For the next question, we are asked to calculate the angle OQS. So let's identify the position of that angle, please. Angle O. Let's just make some clearance here. So here, angle OQS. This is the angle we're looking for. Angle OQS. All right. Now, what I noticed with this angle is that this angle is inside of a triangle that is inside the circle. But this particular triangle is a special type. And this triangle is what is referred to as a isosceles triangle. So right away I can say that, I can write a little statement here. I can say that triangle OQS is isosceles. The mere fact that I've mentioned that they are isosceles, it says to the marker that this student knows that the angles at the base of an isosceles triangle are equal. So right away, I can say here that this angle and this angle, they are both equal. So I know that some division by 2 is going to have to take place. But what I don't have is that if I could somehow find this angle right here, if I could somehow find a way to find that angle, I could just simply take away this angle from 180. Why 180? Because angles within a triangle measures 180. So if I could somehow find this angle right here, I could take this angle away from 180 degrees, and whatever is left, I'm going to divide it by 2 to get this one and this one. So I need to go ahead and try to find this angle here. So I'm going to finish this statement here. Triangle triangle OQS is isosceles. Therefore, based angles are equal. They had said to us in the instruction that we are to give geometrical reasons for each step of our answer. So this is the first statement that's going to bring me to my answer. Now, this angle can be obtained real easily, simply because there is a circle theorem, there's a circle rule that says that the angle at the center of the circle is twice as large as the angle at the circumference, and those two angles must be created by the same chord. I'm going to give you a zoom here and demonstrate to you what that statement is saying. I'm going to put all that back in a moment. So what this is saying here is that I have this chord SQ, and SQ has two lines being projected from both ends. We have a line being projected from S. We have a line being projected from S heading towards Q, and we have another line projecting from the other end of the chord SQ, which is from Q, heading towards the same position O, so it creates an angle at the center. I'm going to call that angle 2x degrees. Now, SQ also has two more lines being projected somewhere else. So it's being projected towards this point up here, R, and then from Q again, it's being projected towards R again. So it creates this angle of 58. I'm going to call this angle x degrees. So that tells me, according to the Substitution rule, is that the angle at the center of the circle, it is twice as big as the angle that is at the circumference, but these two angles must be made by the same chord. And that's what all of that is pretty much saying. Alright, so that's what that theorem is saying. So right away I know, let me just put back all the information I had here earlier. Okay, hold on guys. Alright, there we go. So that's what we had here earlier. So right away I know that this angle is 2 times the size of this one. So I can see right away here that angle O, well, this is the name of this angle, SOQ. Let's write that better. Angle SOQ is equal to 58 multiplied by 2, and that's equal to 116 degrees. And so with this statement at the top, therefore angle OQS, as I mentioned earlier, that if I can find this angle, I just take it from 180 and divide it by 2. So angle OQS is equal to 180 minus 116, and I'm going to divide all that by 2 to get each of those base angles. So 180 minus 116, that's going to give us 64, and 64 divided by 2, and that's equal to 32 degrees. And that is the size of this angle right here, and the size of this angle right here. Alright, and that is how we get the job done. And we have all the statements to back up what we're doing here, and that's for 3 marks. Alright, so pretty good guys, hope you got that. Moving on to part B. So we're on to the bearings section. This is the application of the trig rules, such as the trig ratio maybe, or the cosine rule or the sine rule. Right, so bearings is just really an application part of trigonometry. Okay, so part B here is saying that a ship leaves port A. Here is port A, and it sails 52 kilometers on a bearing of 44 degrees to port B. So the ship is going in this direction here. So if it's sailing 52 kilometers, I can right away, just by reading without even looking at the question, I know that this distance right here is 52 kilometers. What I don't know is where I need to put the 44. Now a lot of students will make the mistake and put the 44 degrees here. Alright, and that's just a typical mistake. I'm sure that perhaps if you're watching this video, you would agree that that's where you would put the 44. If you put it the right place, thumbs up to you. But for the persons who will put it here, I'm going to tell you why that's not where you're going to put it. Number one that you need to understand about a bearing, or about bearings questions, or about bearings itself, is that number one rule is that a bearing is measured in a clockwise direction, starting from the north line. Okay, so bearing is measured in a clockwise direction from the north line. So let's say I have a point and I'm going to call it A, and I draw my north line here, and I'm heading towards another location, but they're giving me the bearing. Please bear in mind that the definition of a bearing is the direction in which an object is traveling using degrees. So I know that once an object is going to move off, like a plane or a ship, the captain or the pilot must establish where north is, and then from establishing where north, you're going to set the bearing. So the captain or the pilot may know that, okay, if this is my north, then that means east is that direction. And in this case, we're not so much concerned about whether it's east or northeast or southeast or southwest. We're not concerned about the actual direction in terms of words. We are concerned about in what direction, or in what estimated direction we are going. So with that said, we know that going east is 90 degrees. We don't need to go that far. This said 44. So I know that 44, that sounds like it's close to 45. So I guess the object is traveling in this direction somehow. Yes? So it's just an guesstimate. And so the 44 degrees would have to be from the north line coming around. It's from the north line coming around until we meet up in the line that leads us to the direction where we're going. So the 44 degrees would be actually on the outside, and that's the reason why. Yes, so the 44 degrees would actually be right here on the outside. Alright, and remember guys, I'm not just working the past papers to just get you the answer. I could just easily out in 2 minutes, but I needed to learn why we say the answers are where they are. Yes, simply because the application in the next past papers, you're going to need it. Alright, so now that we have that, let's leave this information until we need that space maybe. Let's continue. Now the ship is now at B. So there you can see another north line is established by the captain, and it changes the course and it's now going to port C. But going to port C is basically 72 kilometers away. Alright, and now this bearing is 105 degrees. So we have already established our north line, and we just discussed why the bearing is going to be where it is. The 105 degrees is right here because we're going from north. So we're going from north, and we're going to come right around until we are we're going to come right around. Oops. Alright, we're going to come right around until we are touching the line that's leading us to C. So this is 105 degrees. Alright, and that's the bearing. So we haven't even looked at the actual question. We've just placed the information provided to us on the diagram. And here it says on the diagram below, not drawn to scale, right? So you can't use your ruler or your protractor to measure this. You have to label the known distance traveled and the known angles, which we have done successfully. We have picked up 2 marks for that. Alright? So I hope you guys have a proper understanding of what that is. We are now going to be determining the measure of the angle ABC, which is the angle at B. We just discussed that the angle is at the letter that is located in the middle. Now we already have an angle here at B on the outside, so we're pretty much looking for this angle on the inside. Alright, we're looking for this angle on the inside here. Alright, okay, so we need to complete this part of the circle here. Now whenever it is that you're looking for an angle on the inside of a diagram and there's no supporting angles, it simply means that you're going to have to use some sort of geometrical breakdown to get to your answer. Alright, and one of the things, and this is a very common thing that happens in questions like these, there are 2 things you need to look out for. Number 1, you need to know what the different angle directions are, like where does 90 leads you, where does 180 leads you, where does 270 leads you, and you also need to look out for the Z angle. Alright, a Z angle usually is being created whenever we have a north line running in the same direction or the opposing direction with the south line. So the first thing that I see here, let me zoom it up for you. The first thing I see here is that if I can extend my north line here to south, it will basically cut the angle that I'm in search of into 2 pieces, not 2 equal pieces enough, but it's going to cut it into 2 smaller pieces. And what I also establish here is that coming right around here is 180 degrees, because I know that north to south is 180. And I would have had a piece of it already. There you can see I have a piece of it, which is 105. So if I have that 105, I can safely say that this piece right here is going to be 180 degrees minus 105. I know that for a fact. So I'm going to go down here and I'm going to say, alright. So let's write it down here. So that's going to be 180 degrees minus 105, and that's going to be equal to 75 degrees. So this aspect of this angle right here is 75 degrees. So we're going to need to find this portion. Alright, so to find this portion, as I mentioned before, sometimes you have to look out for the Z angle. Alright, now what you can do here is that let me just use a different color ink and just do a little bit of zoom for you here. Whenever you have the north line and the south line on the same diagram, then usually what we see is that they are parallel. Yes, and what parallel lines does is that there is a line that intersects or crosses the parallel line, and then we say that that is the transversal, so it creates that Z angle, Z looking shape angle. Let's take it out for you to see. All right, so that's it there and there and there, so that's a Z. And so the angle, we call these alternate angles, they are equal. All right, so we would have already known what this angle right here is, which is 44. So it's now easy for us to know that this angle here is 44. All right, so with all that said, now we know that angle, we can give it a name. We can say angle, let's call it ABS. Angle ABS is equal to 44 degrees. Give a reason, just write alternate angle or just write Z angles. Alright, and then now we have basically found our angle. Alright, our final angle is going to be, therefore angle ABC is equal to that 44 degrees plus that 75 degrees. And then we go on our calculators, guys. All right, 44 plus 75, that's going to give us a complete angle of 119 degrees. All right, pretty good. All right, so lots of little sketching here and there, and you know, that's just pretty much how you have to look at the question. All right, so we have completed that. We're now going to go on to part 2. So you are to calculate to the nearest kilometer the distance AC. All right, so let's find where AC is. Okay, so here is AC right here. That's AC. All right, so we have the angle in between. All right, and we have the two sides we have two sides of the triangle that pretty much creates the 119 degrees. So what we could do here is that we're going to use a simple formula. This is on your exam paper. All right, we're going to go to the front in a moment and see it. It's called the cosine rule. All right, and what is the cosine rule? The cosine rule is pretty much saying that the square on the unknown side, or we're going to call the unknown side A, so the square on the unknown side is equal to the sum of the squares on the two sides that you know minus 2 times the product of the two sides that are known multiplied by the cosine of the angle created by the two known sides. All right, and just to see where this formula is, we can just check our formula sheets. All right, we're going to check our formula sheets here, and it's right here. Let's go down to the bottom of the page. There it is, cosine rule. All right, a squared is equal to b squared plus c squared minus 2bc times the cosine of the angle made by the two sides. All right, or the angle facing the unknown side. All right, so with that said, then let's go back to our diagram here. All right, so now that we have it, the unknown side here is going to be AC. So we're going to turn this little a here into AC squared. And that's going to be equal to one of the sides that we know was what, 52. All right, so that's 52 squared. Plus the other side is, let me just double check on that, 72. That's correct. So 72 minus 2 times the A, we had called it 52, times the B, we had called that 72, times the cosine of the angle that is made by the two sides. We had calculated that earlier, which is the angle ABC, to be 119. So times the cosine of 119. So you guys can take out your calculator and work with me. So that's going to be 52 squared. Alright, that's going to give us 2,704. And we're going to have 72 squared. That's going to give us 5,184. Alright, so we're going to subtract 2 multiplied by 72 multiplied by 52. And that's going to give us 7,488. And then we're going to multiply that by the cosine of 119. So the cos of 119, that's going to give us a negative number, which is negative 0.484. Right? Good. So now what we're going to do is that we're going to be adding here, and we're going to be multiplying these two over here. All right? So let's add. We're going to have 2,704 plus 5,184, and that's going to be equal to 7,888. We're going to subtract and we're going to do the multiplication here. However, there's a negative here and there's a negative here, so this will become positive. All right, so please be aware of that. So we're going to have 7,488 multiplied by 0.484. That should give us an answer of 3,624.19. Don't forget to write AC squared coming all the way down here. So AC squared. Alright. So we're going to add that now to 7888. That gives us an answer here that AC squared is equal to 11,512, so that's 11,512.19. all right, now to find AC, we're going to find the square root of 11,512.19, and if we find the square root of that number, let's do that. So square root of 11,512.19, that will give us a final answer here of 107.29 kilometers. All right, and that is the distance of AC, and that is for 3 marks, guys. Okay, so this distance here is, let's write it on the diagram, 107, what was that again, 107.29. okay, so 107.29. I do advise you guys that whenever it is that you have worked out the solution to part of the question, please ensure that you put the solution on the diagram. It gives the diagram for me a little bit more life. All right, very good. So we're going to move on to now the third question, or part C, I should think, or part IV. Okay, so now you're being asked here to show that the bearing of A from C, the bearing of A from C to the nearest degree is 260. So we already know it's 260 because you're telling us that's what it is, but we have to show how we'd get that 260. So let's first understand what is meant by showing that the bearing from A to C. This is the part here where I place a lot of emphasis on when I'm teaching my students in a physical space. You guys need to understand that when you're measuring a bearing, you're going to first draw your north line at the position that comes after the word from. So because I'm going to be measuring a bearing, I need to know where I'm going to be drawing my north line, because I am now the captain of the ship. All right, and I need to know what is the bearing that's going to take me to A, but I am moving the ship from C. So I need to have a bearing. I need to establish my north line at C. So the first thing I need to do is to go to my diagram and establish a north line. Fortunate for me enough for this question, a north line was already established right here. There it is. A north line was already established. Alright, and so we mentioned earlier that a bearing is measured in a clockwise direction. So right away I know that what I'm looking for is that I want to go to A. A is this line. This is the line that's leading me to A. So I need to come all the way around here. Forgive me about that. Okay, so come all the way around here to around here. Alright, coming from the north line. So we need that bearing on the outside. So obviously the angle or the bearing that we're looking for is outside of the diagram. It's outside of the diagram. So to find an angle that is outside of the diagram, it means that there's some geometry that's going to have to be that's going to come into play. All right, some geometry, some formula is going to come into play. So let's have a closer look at the question. How can we get this answer? What do you think about when you're going to be approaching this question? Now, the mere fact that the angle is on the outside of the diagram, it means that we may have to use the cardinal degree points to help us. So right away I can see, let me just zoom it up for you here and just try to use a different color ink. Alright, let's use green. Right away now I remember that I realize that this is a north line. So if I were to extend this line here to create a south here, I know that all of this angle over here is 180 degrees. So quickly I have already established a portion of the bearing that I want. So my ultimate objective here is to find this angle right here. If I can find that angle and add that to 180, I should get 260. Now a lot of person will say, all right, this angle is obviously going to be 260 minus 180. But that's not what the question asked you for. The question didn't ask you to find this angle. The question is asking you to show them that the angle going from north all the way around to A is 260. So you need to use a different route to finding this angle here and then adding whatever you have found to 180 to confirm that it is 260. So what do we do in finding that angle? Right now, you remember that even though if you were to draw a line here, right, that's 270 degrees, that's not going to help you. All right, and you can't assume that this line is west. All right, so you're gonna have to do a little bit of thinking here. All right, so let's do some little erasing here. We know that this angle already is 119, and let's put it here. So all of this angle here is 119 degrees. Now we have three sides. All right, let's pay attention to the marks. Sometimes I like to look at the marks to see how much work it is that I have to put in to get this answer here. 3 marks. I know that I'm gonna have to do some work to get this answer. All right, so when I look at this, guys, I'm thinking that maybe, all right, so let's see here. All right, remember we had said earlier, all right, let's remove this 119 and put back our pieces of angle. When we had drawn the south line earlier, we said that this was 44, correct? And we said that this was 75. All right, that's how we got the total angle of 119. But also this 75 creates a Z. So here's the Z here, coming down here and coming down here. So right away this angle on the outside here is also 75 degrees. All right, remember that the total revolution is 360 now, guys, 360. So I've already gotten this piece of angle here. Now this piece of angle in here, we're going to need to find that is inside of the diagram. That is inside of the diagram. We have everything else except this angle. Now here is the plan of action going forward. If I can find this angle, then I can simply add the 180 to the 75 to whatever this angle is that I'm about to find, take that from 360 and find this angle. Now if whatever this angle is, I should be able to add it to 180 to confirm that the angle here is is going to be 260 degrees. So that's the plan of action. The plan of action is to find angle BCA. So that's the plan of action. Hope you understand that demonstration. So let's go about it. So angle BCA, we could use the sine rule for that. All right, and let's go to our formula sheet. Sine rule. All right, so the sine rule here, let's look at it. There it is. I'm going to use the first two because you can't compare three things at the same time. You can only compare two. So we're going to be using this section here. A over the sine of the angle facing A is equal to B over the sine of the angle facing B. So let's do that. So little a over the sine of the angle facing A is equal to little b over the sine of the angle facing BB. So I'm going to call one of my side little a. What side am I going to call little a? Let's call the side that I know here 52. 52 is going to be my little a. So the angle that is facing little a is the angle that I want. So big A is unknown. All right, let's label it little a, big A. Obviously I have the 119, so I want to use this little b and use the 119 as my big B. All right, so let's see here. So little a is 52. The angle that is facing little a is, let's call it sine A. Little b is, we just found it to be 107.29, and the angle that was facing the 107.29 was 119 degrees. So I can work something out here. This is going to be 52 degrees divided by the sine of A is equal to 107.29. I'm going to go on my calculator and I'm going to find the sine of 119. That's going to give me 0.874. Now if I divide these two, I'm going to end up with 52 over the sine of A is equal to, let's get that out, 107.29 divided by 0.874, and that's going to give me 122.75. Feel free to pause the video, guys, and work it out and then look at my solution. All right, that helps you with trying to do the question by yourself. Now what I can do here is that I can do a cross multiplication or I can do a swap. All right, I'm going to do a swap. It's pretty easy. All right, so whenever my unknown variable, which is the angle here, is at the bottom, I do a swap between this and this. So what I'm going to have is 52 divided by 122.75 is equal to the sine of the angle that I'm looking for. Please bear in mind that this step here, guys, is a shortcut. If you were to multiply both sides by sine A and then divide by sine A, you're going to end up with this kind of setup. So I'll just skip a few steps there, just for the purpose that I do not have any space. All right, so go on the calculator. 52 divided by 122.75, and that's going to give me that the angle, that sine of A is equal to 0.423. All right, so I want the angle, which is the angle is A, so A is equal to the sine inverse, so that is sin to the minus 1, 0.423. So you go on your calculator and you press second function, which is usually an orange button if you're on a Sharp or a Casio calculator. I'm using a T184 plus CE calculator, statistics calculator. So I have a second function, all right, on my screen. So I press second function, I press the sine, and then you should see it come up on the screen, sine to the minus 1. I press 0.423. Once the answer comes out, then that angle right there is 25. They said to the nearest degree, so I'm going to use 25 degrees. All right, 25.02, but it's 25 degrees. All right, so that is that little piece of angle that I'm looking for. So this is the angle, 25 degrees. Now, as mentioned before, that the complete revolution is 360. So I need to calculate this angle simply by saying, all right, let's get some space here. Have I run out of space? Have I? Yes, I have. So I'm just going to go over to here to just show you. So this angle right here, that's going to be equal to 360 minus 75 plus 180 plus 25. And that's equal to, let's check all of that one time, 360 minus 75 plus 180 plus 25. All right, let's close my bracket there, and that gives me 80 degrees. So this angle that I've been searching for so long is 80 degrees. Now to confirm what they have said, let's go back to the question. They said earlier that they want us to show that the bearing from A to C to the nearest degree is 260. Let's look at the diagram. What we're looking for is this bearing right around here, all the way the 180 plus whatever this angle is, and now we have it is 80. So if we add 80 to 180, if we get 260, then we have proven our answer. So therefore, let's go back on this page here. So therefore, 180 plus 80, that's going to be equal to 260 degrees, and there you have shown it. All right, that's how you show that the bearing is 260 degrees. So a little complicated, lots of knowledge there to apply. It's just how it is done, guys. If there is another route that you might have seen, please leave it in the comment section. Ask any questions. If you think that maybe it could have been done another way, I'm happy to leave it in the comment section and respond to what you're asking. All right, but that's just the way how I have seen it. Okay, all right, so lots of work, lots of knowledge there, guys. Feel free to watch the video over again to see if you can break it down bits and pieces to follow. All right, if I have left out anything, please let me know. We're going to move on to the next question. So we have finished with the trigonometrical section of the work. Now we're going to move on to matrices and vectors. All right, so let's see what here. So matrices A and B are such that this is the matrix A, which is 3, 2, 5, 4, and the matrix B, which is 4, 0, 3, minus 1. Now you are to show by multiplying A and B that AB is not equal to BA. All right, so in essence, another way that they can ask this question, guys, is to show that AB and BA are not commutative. All right, they're trying to show that when you change the order of multiplication doing matrices, that the results are not the same. So pretty much you're going to have to multiply AB, then you're going to have to multiply BA, and basically to prove it, you can't get the same answer. If for some reason you do, which you won't, then that means something may have been incorrect in your calculation, or maybe it is, well, based on the nature of the question, they're saying that you should show that it is or it's not equal. So they already know it's not, you just have to show it. Yeah? All right, so let's get to work. I'm going to leave you with some very important information that you're going to need to know for future past paper questions if it so pops up. All right, so hope I remember to tell you that. All right, so let's get to work. So we have 4, 3. Where did I get 4, 3 from? I actually have, let's change back to regular. Okay, good. So we have 3, 2, 5, 4. We're going to multiply that now by 4, 0, 3, minus 1. And matrices multiplication is done through rows and columns. All right, so row by column. So we're going to take this row, we're going to take the entries in that row, and we're going to multiply it by the entries in this column first. So you're taking the first row with the first column, so the result should end up in the first row of the first column. It should end up somewhere here. I'm going to write it out for the purpose of this one. For those who are seeing this for the first time, multiplication, I'm going to do the actual detail breaking up, but for the second part I'm just going to run through. Okay, so this is going to be 3 times 4 plus 2 times 3. That's for the first entry. We are now going to give me a second, guys. Having a problem erasing this. Alright, good. Now we already used this row to multiply this column. We're going to use this row again to multiply this column. So we're going to have 3 times 0 plus 2 times negative 1. Now we are finished with this row and these two columns. So we're going to go to this row and this column. So 5 multiplied by 4. 5 multiplied by 4 plus 4 multiplied by 3. And then we're going to just erase here. See, I'm having a bit of problem, guys, just removing that little line in the middle. Okay, so I'm just going to, okay, there we go. So we're going to have this row now times this column. So 5 times 0 plus 4 times negative 1. So that's kind of the detailed breakdown of how you do matrix multiplication. So 3 times 4 is 12. So I'm going to bring this here. So 3 times 4 is 12 plus 2 times 3 is 6. 3 times 0 is 0 plus 2 times negative 1 is negative 2. 5 times 4 is 20 plus 4 times 3 is 12. 5 times 0 is 0 plus 4 times negative 1 is negative 4. Alright? And to wrap this up, 12 plus 6 is 18. 20 plus 12 is 32. 0 plus negative 2 is negative 2. And 0 plus negative 4 is negative 4. So that's the result of A times B. Now, we're going to have to do B times A, but we cannot get this answer as I said before. So we're going to put the B matrix first. That is 4, 0, 3, negative 1. See, we're taking this matrix and we're putting it in front. And then we're putting the matrix A at the back, at the end. So row by column. I'm just going to do it in my head pretty much. I've shown you the sequence, so you can pause the video right now and try to do it this way if you'd like. So 4 3s is 12. Plus 0 times 5 is 0. 4 times 2 is 8. Plus 0 times 4 is 0. 3 times 3 is 9. Plus negative 1 times 5 is negative 5. 3 times 2 is 6. Plus negative 1 times 4 is negative 4. So to wrap this up, we're going to have 12, 8, negative 4, oops, not negative 4 but just 4. 9 minus 5 is 4 and 2. And as you can see, guys, this answer, this answer clearly is not equal to this. So we have shown this result. Lots of work for 2 marks. Like I said, guys, when I'm looking at these questions, sometimes the marks can help you to determine the amount of work, but then again, the amount of work that you had to do here for just 2 marks, I think it's a little bit stingy, but it is what it is. You just want to know that you get the question right. All right, and that's pretty much how you answer number 1. Now you're required here, part 2, to find a to the minus 1, which we refer to as being the inverse of a. So there's a formula for that. All right, it's not on your formula sheet, so you need to have that in your head, guys. So whatever the matrix is, in this case it is a inverse. The formula is going to be 1 over the determinant. We just shorten the word determinant and write det. So it's 1 over the determinant of a multiplied by the adj, that stands for adjoint of a, of the matrix A. So that's the formula for the determinant of any matrix. All right, so we're going to set out here to find 2 things. We're going to have to find the det of A, and there's a formula for that. That's AD minus BC. All right, A represents the first entry of the matrix A, D represents the last entry, B represents the second entry, and C represents the third entry. So if we scroll back up here, we can see that this is A, this is B, this is C, and this is D. That's for the matrix A. So it's going to be A times D, so that's 3 times 4, and B times C, this is B, this is C, so that's 2 times 5. So 3 4s is 12, and 2 5s is 10. So our determinant here works out to be 2. I haven't made any matrices videos as yet, so this is just a formula that you would have probably been exposed to by your tutor or by your teacher or your instructor, whatever the case is. All right, so hopefully you are aware of what this formula is, AD minus BC. We're now going to be finding the adjoint. So the adjoint of A is you take the lead entry. All right, so this is called your lead diagonal. It's 3 4, and you're going to switch the positions of the 3 and the 4. So the 4 goes where the 3 is, and the 3 goes where the 4 is. And then what you're going to do is that you're going to change the signs of the non-leading diagonal. So this is your lead dia, and this is your non-leading dia, or your non-leading diagonal. So you change the signs of the non-leading, and you switch the positions of the leading. So 2 will become -2, 5 will become -5. And that's going to be your adjoint. So to wrap this up then, A inverse is equal to 1 over 2, because det A is 2, det A is 2, times the adjoint, which is 4, -2, -5, 3. All right, we could leave it there if we want to, but they directly ask us for the inverse, which in my eyes means the inverse that is irreversible. All right, so irreversible means I'm going to have to use the half and go inside the bracket. So a half of 4 is 2, a half of -2 is -1, a half of -5, that's 2.5, which is basically -5 over 2. So 2, -1, -5 over 2, and a half of 3 is 1.5, which is basically 3 over 2. All right, and that's your final answer there for that matrix. Okay, it's a bit chugged up, guys, but you get the whole idea of what we're doing here. All right, so pretty good. That's the inverse of A. Now it's just 1 mark for this question that says write down the 2 by 2 matrix representing the matrix product A times A inverse. So what's the result of A times A inverse? This is a fact. This is just something that you have to just know off the bat. The mere fact that it's just 1 mark, it doesn't require you to prove it. So the result is going to be what is referred to as the identity matrix. There's a proof in matrices, all right, that says that A multiplied by A inverse is equal to A inverse multiplied by A, which is eventually equal to what is referred to as I, which is broken down to the matrix, the 2 by 2 matrix 1, 0, 0, 1. All right, that's the result. That's the answer to the question. As it relates to the proof, there are going to be cases where they ask you to prove it. There are going to be cases where they just want you to write it down. So guys, when you multiply a matrix times its inverse, what you're going to get is referred to as the identity, which is 1, 0, 0, 1. And I wanted to mention this earlier to you when I was working this out up here, the product up here. I wanted to mention to you guys that this is the only time that matrix multiplication is commutative. Let's write that down. This is the only time where matrix multiplication is commutative. And what does this mean? What does it mean to be commutative? It simply means that it's the only time that you can take the matrix and change the positions of the matrix and you're going to get the same answer. That's why we have A multiplied by A inverse is going to be equal to the same result as A inverse times A, which will give you the final answer, which is I, which is equal to 1001. There's no other time you can try that and it get the same answer. There it was demonstrated here that AB is not equal to BA. So how can A inverse times A be equal to A times A inverse? Because this is an exception to the matrix multiplication rule. Alright? So, very good. Hope you make note of that. Alright, so we're going to move on now to this section here that says write the following pair of simultaneous equations in the matrix equation formation. Alright, so to do this, we just simply take out the coefficients of the equation, which is 3, 2, 5, 4. And then we're going to write the variables that we're looking for, which is x and y in one matrix. And that's going to be equal to the result of the equation, which is 1, 5. Alright, so that's straightforward. That's just what it is right there. So in order for you to write a pair of simultaneous equation that is linear and linear, we're going to take the coefficients of the linear equations, write them as a 2 by 2 matrix, which is what we have here. 2 rows, 2 columns. Then we're going to take the variable. Obviously, we're not going to write x and y twice because this x is this x, this y is this y. So we just together and write them as 1x and 1y as a 2 by 1 matrix. 2 rows, 1 column. That's why it's called a 2 by 1 matrix. And then equate it to the results that they have told us that it's equal to, which is 1, 5 as a 2 by 1 matrix. Alright? We often refer to this as AB is equal to C, or sometimes they might say XY is equal to Z. Alright? So the product of two matrices, which is the 2 by 2 and the 2 by 1, is equal to a 2 by 1. So hopefully you've seen that somewhere. Alright? And then you have to write the solutions of the matrix equation written in part BI. This is BI. BI. You're going to write the solutions as a product of two matrices. So write the solutions as a product of two matrices. So let's get to it. How much marks is it worth? 2. Bit of work here to do. Now I want to get you to a position here. I'm going to show you a little shortcut, right? Because due to the lack of space, I want to show you how you're going to get the results. Yes? Now, whatever the formation is, B and Y is always the matrix that you're trying to find, because obviously it represents X and Y. Alright? It represents X and Y. So, with that said, if we want to find the matrix B or the matrix Y, whatever the formation is, then that's going to be equal to the inverse of A times, let's just use 1. I'm going to use the matrix AB equals C. So if you want to find the matrix B, then B is going to be equal to A inverse times C. That's just what it is. It's a longer process in terms of how we got to this point, A inverse times C. But this video is not about that. This video is all about just giving you the formula that's going to get you to your answer. So it is A inverse times whatever the matrix C is. Alright? Now, I also want you to recognize here that the matrix A looks like a matrix that we were working with before. 3, 2, 5, 4. Doesn't that look familiar? There it is. 3, 2, 5, 4. Which is the matrix A that we have over here. So it's the same question. And if they're telling us, and if the formula for finding the matrix B is A inverse times C, the question had asked us to find A inverse earlier, which is going to be, we have it right here. This is A inverse. Here it is. Find A inverse. They had asked us to do that a long time ago. So this is the matrix A inverse right here. Now I don't like how this one looks because it has the fractions -5/2 and 3/2. I feel like that's going to make my calculations a bit more complicated. So what I'm going to do, I'm going to take one step back and I'm going to use the inverse of a in its scalar form. So I'm going to be using the A inverse in this form right here with the half on the outside and these whole numbers. To me it's a lot easier. Yeah. So I have A inverse. It's just half multiplied by 4 minus 2 minus 5, 3. So that's going to be a half multiplied by 4 minus 2 minus 5, 3. Let's double check and confirm that we are right. 4 minus 2 minus 5, 3. 4 minus 2 minus 5, 3. Very good. We're good to go. And then we're just going to simply multiply that by C, which is 1, 5. For me, it's a lot easier to work with whole numbers, and that's just my personal preference. Alright? So row by column for this. We're going to leave the fraction for last. So row by column, and then we're going to go row by column again. We just did some multiplication earlier, so you should get the hang of this. So this is going to be half multiplied by 4 times 1 is 4, plus -2 times 5 is -10. Then we're going to have -5 times 1 is -5, plus 3 times 5 is 15. Alright? So now to simplify this, we're going to have a half multiplied by 4 minus 4 plus -10 is -6. And -5 plus 15 is going to be 10. Alright? So pretty much the top result is going to represent x. Top result is x and the bottom result is y. So a half of -6, that's going to be equal to -3. And half of 10 is going to be equal to 5. So therefore the result is that x is equal to -3 and y is equal to 5. And that's the result of the equation. Alright? Perfect. 2 marks, not too bad. But why it's 2 marks is simply because most of the work was already done. It's just really picking up the results that you have already worked out and bringing it over here to make a simple calculation. However, you know, say if you do not, or if you did not get the inverse over here correct, then it would cause a domino effect and everything would be pretty much incorrect. All right, so hope you guys got that. This is not -3/5, guys. This is the top result is -3 and the bottom result is 5. Okay, all right, and that's it. That's it. This calculation, guys, I'm so sorry, this calculation was supposed to be down here. All right, so we're good to go. That takes care of our matrices. Now we're going to go on to the last phase of this entire past paper here, which is going to be the position vectors. We're going to move on to the vector section. So the position vectors of points P and Q relative to an origin O are that vector OP, this is a small vector, OP is 4, 3, 4, 3. So however we get to this position P is by going 4 to the right and 3 up. So this is definitely not drawn to scale. All right, and the position vector O to Q, so from O to Q is going to be 5 to the right, and well, obviously it didn't go up or down, so this is just 5, 0. So this position here is 4, 3, and this position here is 5, 0. All right, that's fine. Let's get to work respectively. The diagram below shows that PR, so from here to here, is 3 times the distance of OP. So whatever OP is, whether it be length or whether it be coordinates, it is going to be 3 times. So from here to here is going to be 3 times the distance, 3 times the coordinates of whatever OP is. All right, fine, we got that. But maybe we could do some evaluation right away, because if we know that OP is 4, 3, so if let's write it here. So if PR is equal to 3 OP, then we're saying that PR is going to be equal to 3 times the coordinates of OP. 3 times 4, 3. So that's going to be 12, 9. Alright, I haven't looked at the question yet, guys. I'm just reading and just analyzing immediately. So the getting from P to R would obviously be going 12 to 9. Alright, so 12 to the right and 9 up. Alright, let's continue. QS is also 3 times the length of OQ. So 3 QS, let's write that down. QS is 3 times the length of OQ. And we know that OQ is 50. So QS is 3 times 50, which right away is going to be 15, 0. So to get from Q to S is going 15, 0. Once again, this calculation that you're seeing here, guys, is just an analytical calculation. It's just reading what I see here and interpreting it in terms of numerical figures. I haven't looked at the question as yet and what's required. So I could be doing more work than what's required, or I could be doing the work even beforehand. Let's have a look at the question. Expressing the form OY, the vector OS. OS. O to S. Alright. So that's not too bad, because OS is made up of 2 parts. OS is going to be the vector OQ plus QS. It's just 2 small lines that make it up. So OS is going to be OQ plus QS. And they want it to be written downwards, XY. So we know OQ. They told us earlier that OQ, here it is 50. And we just established that QS right here. See, this is how it comes into play already. The analytical calculation is now going to make work easier for us here. QS is 15, 0. And so in total, the position of O to S is going to be 20 to 0. Alright? So this calculation here for 1 mark was made easy simply because we had done some analytical calculation. It's always important, guys, that when you're doing a math paper, it's very, very important that you analyze while you're reading. Make jottings, make notes anywhere you can, so that when you reach down to the bottom where the questions are pivotal, then you can make reference to these calculations. And that's why that step was so easy. Alright, so that's the vector OS. Now they want us to find the vector PQ. So this is vector PQ. So because we're looking at the diagram, we're going to have to use what is called the triangle law of vectors. Alright, so using triangle law of vectors, what that states is that if you're looking for a vector, which is in this case PQ, then we have to go around the triangle. So going from P to Q would obviously mean that I would have to go from P to O and add that from O to Q. Alright, so let's write down the formula. P to Q is going from P to O. Whoops. P to O plus O to Q. Alright, now P to O is what we refer to as the inverse vector, because it's the inverse of the vector OP. So we know that the vector OP is 4, 3, right here, 4, 3. So PO would have to be the negative of what 4, 3 is, which in this case is going to be simply -4, -3. Because inverse means opposite direction. So it's just the negative of whatever we already have. Plus OQ was something that was already given to us. OQ is 50. So if we add those, -4 plus 5 is going to be equal to 1. And -0 is going to be equal to -3. So right away, I can see that going from P to Q, I would have to take 1 step to my right. I would have to take 1 step to my right and 3 steps down. Alright, again, it's not drawn to scale, so it doesn't look accurate from the diagram presented to us. Alright, but yes, that's the idea. Alright, so that's the answer, 1, -3. And that's the vector PQ. Proceed. We are asked to find the vector RS. So the vector RS. So let's just do some erase, make sure that you guys have this. So R to S. Again, we're going to be using a triangle law of vector here. So R to S is going to be R to O plus O to S. So let's write down that formula. R to S is going to be R to O plus O to S. Once again, you can safely see that RO is the inverse vector of OR. Do we have OR? Was it asked of us to find OR? We don't have OR. So OR would have to be, that's not bad, because we can easily find that OR is going to be the vector OP plus PR. Right? Because OR is just 2 pieces of line. This little piece here plus this little piece here. So OP we know is 4, 3. And PR we had calculated earlier. We had done it right here. We had gotten 12, 9. Because please bear in mind that they told us that PR right here is 3 times the distance of OP. So it's going to be 3 times whatever this is. So that's how we got the 12, 9. 3 4s is 12, 3 3s is 9. And if we add those, we're going to get 16, 12. That's the vector OR. But we're not looking for the vector OR, we're looking for the vector RO, which is the inverse of OR. So that's going to be -16, -12. And then OS is just what we already know. OS. Do we have OS? We had worked it out here. So OS, we had worked it out to be 20, 0. So if we work that out, we're going to get an answer of 4, -12. And that's the result of the vector RS. Now, at this point, guys, I want you to take a moment and look at how connected the questions are. Notice that a part of our calculations came from our analytical calculation, and a part came from what we had done before. So the questions are connected, yes? And we need to pay attention to the fact that because they are connected, you can't get anything incorrect, because you're going to be using the incorrect information to cause a domino effect on your question. So you have to be very, very careful. All right? But I hope you guys are following the detail working out here. All right? And we only have one question left here, which is, it's saying right here, end of test. So we're about to wrap up the video, guys. It says that we are to state 2 geometrical relationships between the vector PQ and RS. So we're making a comparison. So PQ and RS. So let's look at our diagram to see if we can predict that. PQ and RS. Clearly you can see that the arrows are going in the same direction. So one of the relationships is that PQ is parallel to RS. That's one. And the second relationship, we can look at the ratio of the relationship. PQ we had worked out to be 1, -3. So PQ is 1, -3. And RS is 4, -12. So if you look at it carefully, you can see that RS is 4 times the distance of PQ, because you can see that if I multiply PQ by 4, I'll get 4, and if I multiply the x coordinate of PQ by 4, I'm going to get 4. And if I multiply the y coordinate of PQ by 4, again, I'm going to get negative 12. So clearly you can see that RS is going to be 4 times as long as PQ, both in terms of coordinates and both in terms of length. Alright, so those are the two relationships there. PQ is parallel to RS, and PQ and RS is 4 times the length or the distance of RS. Alright, and that is the end of the 2017 past paper. I do hope that you guys were able to follow along and enjoy the content. Hope this is very helpful towards your exam coming up. All right, whether it be in the January period or the May-June period, I do hope that this was of some aid to you. Coming out next, guys, is the 2018 and the 2020 past paper, so do look out for that. If this is your first time here on the channel, please scroll along right now and hit the subscribe button, turn on the notification bell so that you can be updated when those few videos are going to be coming up. Please share this out to all your friends that are doing the exam, and of course CSEC, CAPE, advanced college level exams, college level math is exactly what we do on this channel. I will do a lot of teaching and live classes. All right, so do share this out, and I will see you next time, guys, in another tutorial session. Please check the description box below for my personal contact, my email address, and my Instagram and social media handles and so forth. All right, so do take care until next time. I keep here signing out. Bye bye.